pedestrian movement. And all of this is sort of a snapshot of live data that was being captured by the sensors, and pedestrians are obviously visualised through this, and all those are real-time sort of movements of pedestrians within a snapshot. The other thing that we've got, that we've also developed on the bottom left, you can see an example of eyewear. This is an app we created to simulate visual impairments. So you use your mobile phone, a VR headset, so it's built for Google Cardboard. You can use it with Android or iOS, and it simulates, as you can see a few examples there, glaucoma, diabetic retinopathy, various variations of AMD, cataract, retinitis pigmentosa. So, and all of these conditions we developed in collaboration with the RNIB. So we went through a number of different iterations of getting the filters as accurate and representative as they possibly could be with the RNIB's eye care team, who has a lot of knowledge in terms of these eye conditions. It's also streaming off from that, so we developed that app, but it's also augmented, so it will take the feed from what your camera is seeing, your back-facing camera on your phone, and it will grab a picture in real time of the real world and then overlay these conditions. You can cycle through different levels of severity, and it's primarily an educational tool to show people what it's like to have these conditions, and also how they would progress if treatment wasn't sought for that particular condition.
Is that something that people can download and try?
Yes. It's available now on Google Play and the iOS App Store.
And what's it called? Eyewear?
Eyewear, yes. We have two different versions, so you can try it for free. There's free versions on both, and there's a paid version which gives you increased functionality. Also, what's led off from that project is the need for architects and designers to be able to build accessibility into what they actually create. Currently, they only really think of accessibility as an afterthought. They've already produced the structure, which then the RNIB comes in and assesses, evaluates, and discovers it's not fit for people who have a certain type of eye condition. It's not accessible. So it tends to cost a lot of money in redesigning and reworking the structure to make it accessible. So the other sort of stream we've got from that is what we did with Judge Street, which I don't think is on these screens at the moment. But we took the CAD model of the RNIB's main office in London at Judge Street, just down the road from St Pancras. And we took that model, reduced it down in 3D Max, and made it compatible, usable within VR. Some of the tools that we integrated into it was the ability to be able to change the environment around you. So you could pick different colour schemes for walls, ceilings, change the materials and textures of floors, and then place objects and design in and around that environment. And in saying that, someone, for instance, if you had a consultant from the RNIB who was also jumping into that instance, they would be able to either sign that space off as being accessible or not, rather than actually doing it as an afterthought. So that's pretty much everything that we're doing in the VisLab at the moment.
Actually, you connected the software, so if you simulate the car, the pod, yeah?
Yeah.
It's using the same algorithm as the software as a real life?
That really is going to be the next stage. So everything that you see with the pods that are navigating around the environment in these instances are just set on set trajectories and paths, and only really for the purposes of assessing HMI. It was just about communication.
Oh, okay.
The next stream of that is going to be to integrate the actual algorithms that are built into the pod, which are sort of other business unit ATS, Automated Transport Systems, is working on at the moment. So they're building all of the autonomous algorithms into the pods, which in time will be extracted from that and built into the environment.
It will be more realistic as a testing the pod, how it reacts to people, like you try
Exactly.
to do it, yeah, so you know, jump in front of it, or the bicycle jumps in front of it, so you see how it reacts comparing with the...
Exactly. So then at that point, the actual physical algorithms that are built into the pod are directly matched by what you would see its behaviour acting in VR. So that's the next stream, really. So if you've got any questions about sort of anything else that we do here or any of the equipment, we also work with a number of different VR technologies. So some of the stuff you've seen here is obviously the main centrepiece is the OmniDeck and what we have with the vehicle sim. We're also working with a number of different VR, AR, MR systems. The VR systems being the HTC Vive and the Oculus Rift, but we also work with the HoloLens,